Hi folks, in this video, I'm going to show you how to perform an independent samples t-test in Excel and then how to verify it in JASP. So in the context of this research question, a group of researchers were interested in knowing whether a directed reading strategy was better at reading comprehension compared to a traditional non-directed strategy. And so with directed reading, the reader is encouraged to activate their knowledge and determine and reflect upon what they know, what they think they'll know, and begin to form connections with what they learned in other concepts of what they've read. And so a directed reading approach challenges readers to activate their knowledge in terms of what they know, what they think they know, to predict what they think that they will learn, and to reflect and connect on what they know for certain that they learned. And so a group of researchers took 44 individuals and they assigned them to either directed reading strategies or to control strategies. And at the end of the intervention, they assessed the reading performance of both groups. And in order to calculate these values, the researchers will need to use two formulas. One is known as the pooled variance formula, and the second is the actual t-test formula. And so we'll go ahead and jump over to Excel and show you how to do that. Okay, so if we start with a blank Excel sheet, I'm just going to copy and paste and move those data over here. This is the example data set. In a real research scenario, you would recruit all 44 of these participants. You would do the randomization and the group coding. So let's say that a group code of 1 was the treatment group, which is the directed reading activity, and a group code of 2 was the control or usual standard of care for how reading is done. And then in a real research scenario, you might do your coding groups yourself. So you can see here that a 0 is assigned with the treatment group and a 1 is assigned with the control group. And the dependent variable of interest, which is reading performance, that's our DRP variable, that is our dependent variable of interest. And so once again, if I come over here and I move these formulas over to Excel, I can go ahead and start to generate some of these data. Okay, and so we always start and build upon everything that we know. And the first thing then I want to think about is, what do I need in order to determine the pooled variance formula? Well, in this case, I need to know the sample size for the first group. I need to know the variance of the first group. I need to know the sample size for the second group and the variance of the second group, right? That's going to get me pooled variance. But I also need to know the mean of the first group and the mean of the second group later on in order to generate this. And so what I'm going to go ahead and do is I'm going to just quickly fast forward here and generate these values as such. I can see that my dependent variable of interest, which is my reading performance, that's reflected with this DRP variable here. And so in order to calculate the values that I need to generate pooled variance, there's a couple of pieces that I need, right? And so in order to generate pooled variance, I'm going to need the sample size and the variance of group 1, and I'm going to need the sample size and the variance of group 2. And so in order to do that, I also see later on, I'm going to need the mean of group 1 and the mean of group 2. So I might as well calculate all of those together. To go ahead and do that, let's go ahead and calculate our treatment group, which is the directed reading group, and the control group. And what do I need here? I'm going to need the mean for both of these groups. I'm going to need the variance for these groups, and I'm going to need the sample for these groups. Okay? And so in order to do that, let's go ahead and set our cell equal to average. And when I go ahead and set that cell equal to average of my 21 participants, you can see that I get 51.476. There are 21 people in this group. And similarly, if I do the same for my second group, I'm going to take the average from 22 down to 44, close that, and I have 23 people in that group. So the part that I need to take the time to do then is I need to be able to figure out variance. And so in order to calculate variance, I might make my life a little bit easier and take these 21 participants and maybe move them down here or something, right? And I want to be able to determine deviance, and then I'm going to need square deviance so I can get sum of squares total, and then I can calculate the variance. And so in order to do that, remember, we take equals this particular cell minus the mean for the treatment group, which in this case is $H $3, and you see that the mean is highlighted in red. And I'm going to run that deviance down for all 21 people in the data set. I'm then going to square the deviance, so multiply it by itself. Once I go ahead and do that, I'm then going to take the sum of the square deviances, which is my sum of squares total. And I'm going to determine variance, which is the sum of squares total divided by n minus 1. So in this case, we had 21, so 21 minus 1 is 20, and we get 121.161 as our variance in that equation. We'll go ahead and do the exact same thing for the control group, and we have data for 23 individuals. So if we take that data and we need the deviance, square deviance, and variance, once again, we're going to set the cell equal to this value minus $H $11 in this case. And you can see that that is also highlighted as such. We can run that number down for the remaining data points. We'll need to square the deviance, so multiply these values by themselves. We'll need to run that down and sum that. Okay, so if we sum that, get sum of squares for the second group, and then we take the variance, which is taking the sum of squares total and dividing it by n minus 1. So in this case, we have 23 minus 1 is 22 participants in that case. So the variance in group 2 is 294.079. Okay, so now that we have done the work to get the parts that we need for the pooled variance, we can go ahead and try to calculate pooled variance. So to calculate the pooled variance, I like to address things from the numerator first and then the denominator. So to address the numerator, we're going to open our parentheses, and the sample size for the first group is 21 minus 1, close parentheses, and multiply it by its variance, right? I'm going to do the same thing for the second group. And so that's going to be equal to, open parentheses, n2, 23, minus 1, and multiply that by its variance. And then if I take the sum of adding both of those up together, you can see that I get the numerator taken care of here. So this is our numerator, right? Then for the denominator, right, all I need is n1 equals n1 of 21 plus n2 of 23 minus 2. And you get your denominator of 42. And so your pooled variance is going to be numerator divided by denominator. When you do that, you get a pooled variance of 211.7375553. So now that we have pooled variance, we can then carry this over and use that to perform our t-statistic. And so once again, in order to calculate our t-statistic, we have to take mean 1, which is the mean for the first group or the intervention, minus the mean for the second group, which is 41.521. So that's simple enough, right? That's our numerator. And then for our denominator, what we first want to do is we want to take the pooled variance, which we just calculated, and divide it by the first n of 21. And then we want to do the same thing and take the pooled variance divided by the n of the second group, which is 23. And we want to sum those two together, add them together. And when we do that, you can see that we get 19.2887. But then we have to take the square root of that value, and that's going to make up our denominator. So when we do that, we get 4.39. So I'll highlight these pieces here. So that's your denominator, and this is our numerator. And so to calculate the t observed, t is going to be equal to taking the numerator divided by the denominator, and you get a 2.2666516 value. Okay, so then we would go through the same process of just taking the data here in Excel, not the calculations, the data, and then converting it to a .csv file, and then from a .csv file, getting it into JASP. But for purposes of this example, JASP already has these data pre-populated. So go ahead and open up JASP, which we have here. And we're first going to start by verifying our means and our variances. So to do that, we're going to go to descriptives. We're going to take our dependent variable, which is the DRP reading measurement, move it over to the variables box, and we're going to split it by group. Okay. And so when we split it by group, we're going to have the ability to see the means and the standard deviations of each group, which is easier to verify for purposes of this assessment. We can also go ahead and select variance, since that's something that we calculated in this case, and we can put these side by side with our Excel file. And so if we first look at these data here, which is the means and the standard deviations, you can see that the mean of 51.476 is going to match the mean for the treatment group. And similarly, the mean of the control group of 41.522 is also matched. If we look at the variance, you can see that the 294.079 matches the variance for the control group that we have in Excel, and the 121.162 we calculated in JASP also matches the values that we have in Excel. So when things match, that means you're on the right track here. Okay, so in order to run the t-test, we're going to go to t-tests, independent samples t-test. We're going to take our dependent variable and move it to the dependent variables box. We're going to put our grouping variable into the grouping variables box, and we're going to get our t. Because this is a independent samples t-test, we have to check the basic assumptions of normality and equality of group variances with the Levene's test. And so when we explore these data, you can see that when we first check the homogeneity of the variance assumption, you could see that the p-value of 0.132 is statistically non-significant, which tells us that the variances of these groups, 294.079 and 121.162, that the variances are not statistically different from each other between the groups, which means we can make a fair comparison between the data collected. Similarly, when we check the assumptions, here we can see with the Shapiro-Wilks test that a p-value that is larger than 0.05 indicates that the distribution of data for these samples is not statistically different from a perfectly normal and ideal distribution in the population. So that means that we have a normal distribution. So the next thing we need to think about then is let's go ahead and explore the t-statistic itself. And so you can see that the t calculated is negative 2.267. And if we jump back over to Excel, you can see that our t-statistic is 2.267. Now, notice that it's negative in JASP and it's positive in Excel. That's completely okay. I assigned X1 to the treatment group and X2 to the control group, and JASP preferred flipping it in the opposite direction. It is correct either way. The absolute value does not change your interpretation of the data in any way, shape, or form. So when we look at the p-value, you can see the p of 0.029 is smaller than 0.05, which declares a statistically significant difference in the data collected. Now, one of the things that we would think about for our t critical value in determining if our t observed exceeds the t critical value is we have to use our t table. So if we use if we used a two-tailed test with an alpha of 0.05 and we had n1 plus n2 minus 2, we had a total of 44 minus 2 is 42 degrees of freedom. We would explore and probably go with this 40 line since it's closer to 40 than it is to 60. So if we follow the intersecting points of those values, you would see that the t critical value is 2.021. And so definitely 2.021. And so in this case, 2.2665 exceeds 2.021, which again is a statistically significant difference. So regardless of whether you're just comparing the t observed to the t critical value, or if you are going to JASP and you're just reading the significance value, Both ways are completely appropriate. And what it means is that there is a statistically significant difference between the groups with respect to reading comprehension. And so which of the groups had a more advantageous response? You would explore the means. And you can see that people that participated in the treatment or the directed reading activity, that they had, on average, a higher reading comprehension score compared to people that performed a traditional reading without directed reading strategies activity. And so that is how you would run an independent samples t-test in Excel and verify the data in JASP. So I hope this video was helpful, and we'll see you all in the next one.